All right, for this lesson, we're going to be solving systems of equations by substitution. So we're going to be substituting. So if we look at this, we're solving two linear systems. So last time we did graphing, two lines to see where their solutions were. Our three different answers were no solution, infinite number of solutions, or one solution, which was a point xy. So this one, we're going to substitute one expression in for the variable of another. So let's take a look at this one. If y equals 3x, we're going to draw a line right here. Since y is the same thing as 3x here, we're going to put 3x in for my y because they mean the exact same thing. So I'm going to get x plus 3x equals negative 32. Well, this is the same thing as having a 1x. X plus 3x is 4x. So 4x equals negative 32. We've got to get x by itself. X equals negative 8. Well, my set always comes in points, so we have our x point. Now we got to figure out y. So we're going to plug it in for x, because this way we can figure out what y is. 8 times negative 8 times 3 is negative 24. So our point then would be negative 8, negative 24. So if we were graphing that to figure it out, that would be really far off our graph. So that's why we're learning different ways to find the solution of these graphs. Okay, so again, my y is represented for 3x, so let's go ahead and plug this in for my y. We get x plus 3x equals 8. X plus 3x is 4x. Got to get x by itself, so we got to get rid of the thing in front, so x should equal 2. Once I figure out what my x equals, I got to find my y, so let's plug it into the original equation because it would be easier. 3 times 2 is 6. So my answer then is 2, 6. Again, if you want to check it, plug it in. I suggest checking your answers just to make sure that you added everything right, you multiplied everything right, divided everything right. Okay. So this one, it looks like we don't have a variable by itself. So our first step is always isolate a variable. So if we're looking at this, we want to isolate one that doesn't have a number in front, if possible. So it looks like this y doesn't have a number in front, so we're going to isolate him. So to get rid of this negative 2x, let's go ahead and add 2x to both sides. Well, negative 3 plus 2x is just going to be negative 3 plus 2x because the negative 3 doesn't have an x attached. So they're not like terms that they can combine. So we're just going to have negative 3 plus 2x. Well, now I have a term isolated. So let's represent this in for my y right here. And whenever we do this, we're going to put it in parentheses, because that 3 has to distribute. So this y just substituted in for the y here. Okay, so now we're going to distribute. So we're going to get 3 times negative 3 is 9. 3 times 2x is 6x. And we still have our 4x equals 14. If we add our like terms, we're going to get negative 9 plus 10x equals 14. Let's add 9 to both sides. And I'm going to run out of room. So 14 plus 9 is 23. Divide by 10. Our x should equal 2.3. Okay, well now we have to find, it has to be a point, so we need to find our y now. So let's go ahead and plug it in for this equation because y is by itself, so it's easy to solve. Oops. Okay, so 2 times 2.3 should give you 4.6. Negative 3 plus 4.6 should give you 1.6. So then my y should equal 1.6. Again, check your answers. Plug them back into both original equations and make sure both sides equal each other. Okay, so first step, isolate a variable that doesn't have a number in front. So do I have a variable that's isolated? Well, it looks like x is isolated. So let's go ahead, since these two mean the same thing, plug this in for x. So we're going to have 3.5 times negative 2y plus 4 plus 7y equals 14. So we're going to have to distribute this. So I'm going to get negative 7y plus 14 plus 7y equals 14. Combine our like terms. Since they're on the same side, we're going to do what it says to do in front. We're not going to add the opposites or anything like that because they're on the same side. We're not moving from one equal sign to the other side of it. So negative 7y plus 7y is 0. So I'm going to have 14 equals 14. Does 14 equal 14? Well, yeah. So my answer is going to be infinite. Well, infinite means that these two lines should be sitting on top of each other. So they equal basically the same thing because they will be sitting on top of each other. They will have an infinite number of solutions. Okay. So first step, do I have a variable that's isolated? Well, it doesn't look like I do. Second step, is there one that I can isolate that does not have a number in front of it? Well, it looks like this x doesn't. So can we subtract this 3y over? 4y minus 3y is just y. Now I have a variable that's isolated. So we can plug this in now for my x. Again, we put it in parentheses. So we can distribute. So we get 2y plus 6 plus 4y equals 18. Combine our like terms. 2y plus 4y is 6y. Subtract 6. 6y equals 12. Divide by 6. Y should equal 2. Well, we have to figure out what our x is, so let's go ahead and plug it back in here. 2 plus 3 equals x. X equals 5. Again, check your answers by plugging them back in. Okay, it looks like this one's by itself. So let's go ahead and plug this in for my y. So we're going to get 2 times 1/2 x plus 3 minus x, because we can't forget about him, equals 6. Distribute our 2. 2 times 1/2 is just 1x. 2 times 3 is 6. Now we combine our like terms. X plus negative x, well, those will just cancel. Does 6 equal 6? Yeah, it does. So our answer is going to be infinite. If they wouldn't have equaled each other, so say it would have been 5 equals 6 or something like that, 0 equals -1, anything like that, our answer would have been no solution. Kind of like how it was in the graphing section.